Alrighty, so today we are simply going to define what ions are, and in addition to that, we're going to learn how to write down the formulas for ions. First of all, what an ion literally is simply any atom that has a net electric charge. The entire class, we've been dealing with atoms that are completely neutral in nature, so they have a charge that's essentially zero. This is because the number of protons and electrons are equivalent to each other. Now we're going to deal with atoms that have a charge associated with them. Now, charges are obtained when you either lose or gain electrons. The loss of electrons is going to lead to a positive charge, and the gaining of electrons is going to lead to a negative charge. And this should make sense because electrons are negatively charged, so if you lose something that's negative, you're inherently going to become more positively charged, and the opposite is true. If you gain an electron, you're adding something that's more negative, so inherently you should get a more negative charge. We are going to consider that each electron has a charge of -1 associated with it. So if you gain 1 electron, you now have a charge of -1. If you gain 2 electrons, you now have a charge of -2. The same goes for losing electrons. So if you lose 1 electron, that's a charge of +1. If you lose 2 electrons, that's a charge of +2 electrons. Or sorry, +2. Now we have two types of ions. Remember that an ion is just anything that has an electric charge. The first type of ion is known as a cation. Cations are positively charged, and these are formed by losing electrons. And so cations will form when an element loses all of its valence electrons and essentially empties its valence shell. Now, the only elements that are ever going to lose valence electrons are going to be your metals. If you do not know how to spot your metals on the periodic table, I can quickly show you. You should hopefully have a line on your periodic table that extends in the following way, where it does this staircase. This poorly written line. Anything to the right of this line is a nonmetal, and everything to the left of this line is a metal. What that means is everything to the left of this line is going to lose electrons. Specifically, it's going to empty the valence shell. If you don't know how to find the number of valence shells, that's a pretty simple task. You just use the group numbers. So group 1A has 1 valence electron, group 2A, 2 valence. You skip all this. This is 3A, so this would be 3 valence electrons. 4, 5, 6, 7, and a completed shell would be 8. That's essentially just simple reading of the periodic table. Make sure that you are comfortable doing all of this. Now then, back to the slides. Again, cations are going to be formed when a metal loses all of its valence electrons. To contrast with the cations, you have anions, which are negatively charged. Now, since you're getting a negative charge, this means that you are gaining electrons, and anions are going to gain electrons until a completed shell is pretty much made. A completed shell is defined as 8 valence electrons. So you would essentially count the number of valence electrons that you have, and then start adding until you end up with 8 valence electrons. And anions are going to come from nonmetals. So hopefully you're looking at your periodic table, and anything to the right of the line that we had drawn is going to be a nonmetal. Now, before we go into actually forming these ions, we do need to go over some rules as to how to write the formulas for ions. The first rule is that the chemical formula remains exactly the same. So what that literally means is that if we were comparing sodium, which has the formula Na, to its ion, sodium ion, they would both basically have the same exact principal formula, which is simply Na. Now the next thing is that the charge is going to be written as a superscript. If you don't know what a superscript is, it's simply just text that's written directly above the regular text. Most of you guys should be familiar with how exponents work, so something like 10 to the second power. This 2 right here is an exponent, and it's literally written as a superscript. So as you can see right here, this 2 would be considered as the superscript in the situation. So just follow all the same rules that you would for exponents. The next rule is that the charge quantity is going to be written first, followed by the type of charge. So if you have an element that has a charge of +2 or +2, you would write it like so. You would write it as a 2, then a plus sign. You write the quantity followed by the sign. If you had a -2 charge, then you would just say it would be 2 minus. It would be the 2 followed by the sign. There is one exception to the rule, which is ones. Ones are simply just not going to be written at all. So if something has a charge of +1, you would just write, instead of +1 or 1 plus, you'd simply just write a plus sign. So what that means is sodium ends up having a charge of +1. When you write down the ion form of it, you would just write Na plus. Now we're going to go into the specifics as to how to determine that sodium has a +1 charge, but just take that into consideration right now. So here's our example that we had highlighted already. This is sodium, Na, being turned into sodium ion, Na plus. If you want to see another example, we have magnesium. Magnesium's ion has a charge of +2. So when you write down the ion for magnesium ion, it's going to be Mg2+. As you can see, for both of these situations, the actual charge is written as a superscript, while the chemical formula stays exactly the same. So now let's go ahead and run through some examples. So the goal is to calculate or write the formula for each one of these ions. Now, this is a couple of steps that you need to take in. The first thing that you need to do is you need to determine whether your element is a metal or a nonmetal. You would obviously do this using the periodic table. After you determine whether it's a metal or nonmetal, you have to determine whether it's going to lose electrons or gain electrons. You should hopefully have it copied down from the last slide that metals are going to empty their shells and lose valence electrons, and nonmetals are going to complete their shells and gain valence electrons. Then after you do this, you would count the number of valence electrons, and afterwards you would just simply see how many electrons were gained or lost. The number of valence electrons that were gained or lost is going to be directly proportional to the quantity of the charge. So if we wanted to run through the first example, which is lithium, first we have to find lithium on the periodic table. So if you find lithium, it'll be right here. Boop, boop, bam, bam. As you can see, it's clearly to the left of this line that you should have written on your periodic table. So lithium is very clearly going to be a metal. In addition to that, because lithium is in group 1A, it has 1 valence electron. So we now have all of the information required to solve for this problem. So if we go back to our slides, we already know that lithium has 1 valence electron. We know that it's a metal, so it's going to lose that 1 valence electron. And so when you lose 1 valence electron, you get a +1 charge. So the formula for lithium ion is going to be Li plus. We can go ahead and do calcium also. If you look at calcium on the periodic table, I'll just quickly zoom into that. I'm not going to erase this content. But if you go to calcium on the periodic table, you'll see that it's right here in group 2, meaning that A, it's a metal, so it's going to lose electrons, and B, it has 2 valence electrons since it's in group 2A. So, since we know all these things about calcium, we know that it's going to lose all of its valence electrons, and we know that it's going to lose a total of 2. When calcium loses 2 valence electrons, it gets a +2 charge. So it's going to be written as Ca2+. For oxygen, a little bit different. Oxygen is a nonmetal. So when you spot oxygen on the periodic table, this is getting a bit messy, you'll see that it is very much to the right of the line that we are talking about. It's located right here, and it has, let me erase the box, it has a total of 6 valence electrons. Remember that nonmetals are going to go by slightly different rules. So with the metals, you just basically emptied the shell. However, with the nonmetals, you're going to gain electrons until that valence shell is complete. Remember that we had previously stated that oxygen has 6 valence electrons, and you want to complete the shell. The way you complete the shell is by gaining an octet, 8 valence electrons. So in order to go from 6 valence electrons to 8, you obviously have to add 2 brand new electrons. And so when oxygen gains 2 electrons, it gets a -2 charge. So the formula will be O2-. I recommend pausing the video right now, as I'm just gonna quickly blast these answers. Okay, hopefully you unpause the video and tried these by yourself. For bromine, you should have gotten that it's a nonmetal with 7 valence electrons. Since it has 7 valence electrons and it's going to gain electrons due to it being a nonmetal, you just add 1. So it'll be Br-. And then for aluminum, it's a metal with 3 valence electrons. Since it's a metal, it'll lose all of its valence electrons, so it'll have a +3 charge. So this should be Al3+. Okay. And that's going to wrap it up for actually forming ions. This is going to be very important when we start forming ionic compounds. So make sure you are very proficient at being able to write down and determine these charges.